Hello, my friends! 3D printing is an ever-increasing industry in our world today. It seems like we've come down from the astronomical costs of original 3D printers to more manageable costs of $200 to $500 or $600, and then you can go into the premium ones which start to break $1,000 and beyond. And if you're really interested in heavy 3D printing, you can buy some for like $10,000. Although the good thing is, I think the $10,000 ones are capable of printing in steel, like stainless steel, but that's besides the point. Let's stick to just PLA. As 3D printing grows in its own way, we are starting to see more and more applicability to our real world of using 3D printing besides just toys. The simple reality of it is like we're starting to see cars, and we're starting to see aircraft, and we're even starting to see 3D printing being used in space application. So really it's a creation's limit. We are starting to even see reports of NASA wanting to have 3D printed buildings on planets before the astronauts get there, which is a great idea. I mean, you can have a little bit of protection, and then all you have to do is set up certain things, and voila, you have a space station on the moon or on Mars or wherever else we decide to go. Cool thing is even now on Earth, we have things that are being built like houses. Somebody built a 3D printer using concrete as the medium, and it's like, that's really impressive. And when that 3D printed house is built, it is built with all the necessary holes in the walls for lighting and electrical and plumbing to be able to be installed. And the house is almost done when the walls are finished by 3D printing. You throw a roof on top, throw the doors and windows in, and you're good to go. It's pretty quick. For right now, today, we're going to talk about how I set up my 3D printing in just the smaller applications that I have with my 3D printer. I bought a Creality CR10 a couple of years ago, and I've been off and on just using it here and there, and I've probably printed, I don't know, at least well over 200 or 300 things in the last couple of years. Well, I bought the printer used so that I could buy it at a discount. It has held out, and I've had to replace very few components on this printer, even though it still has had troubles, and I've had to replace some components. It's surprising just how long the longevity of a 3D printer, how long it lasts. It really is an awesome printer, and I really enjoy having it. While I have modeled things for myself, like this Sushi Go case for the card game Sushi Go, I have also found a website that has really great models. Some of them are not great, but they have mostly great models that actually are useful to use here, there, and everywhere, and they have a whole bunch of toys. So let's go look at it. This website is called Thingiverse, and Thingiverse is a completely free website. You don't have to sign up for anything. You don't have to have an account or whatnot. But the beauty of Thingiverse is you can search for what you're looking for, and there's a chance you'll find something close to what you need or exactly what you need. And you can also just discover a lot of fun things. There's all sorts of toys and different little creations and different ways of doing things that is presented by the many people that contribute to Thingiverse. On Thingiverse, my wife found this beautiful jewelry holder that she wanted printed out to give to a friend. So I took the time to print it out, and here we go. Let's look at the settings before I show you the footage of what I printed. After we get done with this, I will show you the time-lapse photographies of this build and another build coming up. Okay, so this is Ultimaker Cura. I chose to go with Ultimaker Cura because it was really the best program that I ran into when I started looking for a slicer. A lot of the slicers that existed when I first started 3D printing were pay to use, and I was not fully set on doing any pay to use. And so I chose Ultimaker Slicer to get started, and I fell in love with the program. I really like this program. I feel like the interface is nice and easy to use. It's at least for an interface to set up printers and whatnot, I've found that this is a good one. for me at least. There's this settings. It might look like this when you first start it up. This little pencil over here is how you open up the settings for preparing your printer. Some of the most important ones usually show up already in this list. So if you ever need more settings, you go to this Manage Settings visibility through the 3 bars on the right, and you can see you have lots of other information and settings that you can change. And when you select one of these, you actually add it to this list, and then you make the edits to it. If you don't quite know what some of these are for, especially the ones that have an I next to them, will give you the information based off of what that's supposed to do. You start out with your layer height. You can either set your layer height through the top here, or you can specifically set your layer height exact. And every time you do try to change these defaults, it will ask you if you want to reset others that you have changed. And so you can reset a lot of your things to what the default initially had set up. I rarely tend to touch this section because most of the time these settings are pretty good. If I do find that a print that I'm going to be doing multiple times came out with walls that were too thin and I felt like it needed a little bit thicker walls, I can change those settings here. I can change the top thickness and bottom thickness, and it's pretty straightforward. But a lot of the times I find myself leaving most of this alone. I have played with the enable ironing, and sometimes it's really cool, sometimes it's a little bit tacky. I've had hit and misses. Infill density you will use quite often. 20% is a usual good one to have for like the inside. It's supporting information on the inside of the model. So these holes are areas that we'll never see again, and we don't need this to be solid. So you can have a lot less material on the inside, and by reducing the infill density to the lowest you possibly can, you make it so that the model is lighter, cheaper, and you're not taking up a large amount of extra time. You do need to consider how much infill density you need, because the infill density acts as your support when you finally start doing the layers that will cover up the inside hollowness, okay? And you only have so much distance before you're going to have troubles with extruding and stuff, and it will droop. And that's why you want to pick a number that is good for your printer and make sure that it doesn't exceed the distance that will cause problems with the print and maybe fail your print. Later down here we have your initial temperatures. I tend to double check the wheel of PLA that I'm using, because I have multiple different types of PLA from different companies. And while PLA is PLA, not all PLA prints at the same temperature. So I double check and I pick a number relatively middle to what the PLA reel says, just because that's, for me, a good place to start. The bed temperatures at 50 Celsius is pretty good. You can change it so that it's hotter for the initial layer if you want. Print speeds, I usually go with the intuitiveness on this one. The way they set it up seems to do pretty well. There are a few times where I feel like I need to bump it up just a hair. Enabling retraction helps reduce stringing between different parts. So, like, especially like the towers that are going up here, if you didn't have the retraction, when this print would finish, there would be all these little strings stringing across these two pillars. And in the time lapse that I'm going to show you, I failed to turn off the stringing, or I failed to enable retraction on layer change, which is this one, and that caused me to have some stringing in the back that you'll see in the video, and I tried to take it off in some of the pictures. The retraction distance is a variable that you want to pay attention to. Sometimes you'll find that you still get stringing even though you have retraction. And this is one place where you would gently bump that up to higher numbers as you make future prints and just record how you feel about it. Working our way further down, there's print cooling. Usually you're going to have print cooling enabled because this helps turn your liquid PLA into more of a solid before the printer comes around and prints on top of it again, which would be really bad and causes really messy prints. Generate support. This is valuable for situations where if you happen to have overhangs that you know would fail the print. Okay, if I tilt this on the side so that these towers would fail, I would need to print supports to make sure that they wouldn't droop as it's trying to print these pieces. And you can see these supports are just a tiny hair away from the actual print to allow it so that it snaps off easily when you're done. But generating support is always a wise idea, especially when you have overhangs that you know will fail your print. They are kind of like infill, and if I zoom down a little bit, you'll see they kind of have a slight infill-like structure to them, but their goal is not to be part of your model, it's just to facilitate the build of your model, and you remove these afterwards. The build adhesion type is kind of an important one depending on the situation. I use skirt for the most part because that gives me the opportunity as the printer's starting, it does these 3 lines out here. And while it's moving around those 3 lines, I will, with my finger, just test and feel what the thickness feels like on the build plate, and I'll level the build plate before it starts printing. And that way, I know that when it starts printing this first layer, that I'm going to get good adhesion for the print. But skirt is not the only thing that you can do. Brim is really good for parts that have a really small profile on the surface of the print bed. What the brim does is it just prints a large pad, as you'll see in just a second. It prints a larger pad out from the main part, and it gives it this more landing that will help adhere it to the plate for the whole print. And then you can see the print would just go up from there. On parts where you're worried that the build plate is going to cause extra warpage, raft is a good one because what it does is it prints a couple of layers off of the main build plate, still lets you keep and reap the benefits of the heat from the build plate, but then it allows you to start building on top of this extra surface. Another beauty of using raft is it will give you a flat surface to start from for your main part. And without further ado, let's look at the 3D print. The Lord of the Rings print was really interesting to do. It's a very simple print. There's not a huge amount of difficulty with it, especially since that tree sits flat on the table. You don't have any overhangs whatsoever, and the main base just built up perfectly fine. It was an excellent print. How it works for the intended recipient, we will have to see. I don't know yet because that's going to be something of a Christmas item for this friend of my wife's. We're getting long enough that we should probably make a part 2 where I will save to the disk, move it to the printer, and set up the printer directly on the printer and get everything heated up and start the print. And we'll do that with a different model because we don't need another jewelry stand. So, but wait, before you go, I've got another print. We recently have had troubles with our Splendor box. This is a very fun game, and my kids love to play it. But, as I said, kids are not very careful with boxes, and my box is starting to fall apart. So I have, and even then, this is also a family favorite of my family, and my siblings have copies of this game. And the other day, my sister she's like, hey, my box is totally disintegrated. Is there anything you can do? And after a quick search, I found online that somebody had already produced a Splendor box compact. And to show you a size comparison, this will take this size box down to this little box. I mean, that is awesome. So the other cool thing I did with this particular time-lapse photography is I have already made two of them. I made one black and one yellow, and the black one I did in the old style where I had the GoPro mounted to the heat bed and the GoPro moved around with the heat bed. This new style is going to be based off of what you just saw in the Lord of the Rings. That's the yellow one. You'll get to see it as almost a slideshow going all the way up to the full build. This is going to be really fun. So here we go. A huge shout out goes out to Devon Montes, who inspired the idea of this new style of time-lapse photography and my adaptation of it. I'll show you how I did the adaptation in a future video. Okay, so that being built, this is what it looks like when it's filled. You can see that, you've got your base, some of the cards fit down here in the bottom. You've got your main coin holding area up here, which I will put the red coins in. And I had to move, I moved, because the gold coins are slightly less, I moved one of the green coins over to the gold side. That gives you a little dip to get out your cards later. And then all the main cards of the game go up here in the top pocket, just like that. Isn't that really awesome? And then, of course, the whole thing fits together and it stays well. I love it. So, that's all I've got for you today. Thank you for watching today. This has been an interesting experience, trying new things, getting new styles, and trying a different camera position. And this is just progress. Like, I've even bought, like from DI, I bought a couple of lamps so that I could get a little bit more lighting around here and hopefully light up the face a little bit more. This is exciting. It's good to have you here. We'll see you next week, friends. Have a good day. Bye. 3, 2, 1, and ouch! That was not what I want to do. Ow! Oh, that hurt. 3, 2, 1, and